Newton the Mouse and his adventures through physics. There once was a mouse named Newton who lived in a house made of cheese.
Newton always dreamed of going to a carnival, but Mama Mouse wouldn't let him. One night, Newton was feeling mischievous, so when the clock struck 12, Newton the Mouse snuck out of his house.
The entrance to the carnival had a very long line, which took him a lot of time. His movement on the line from start to finish measures his displacement. Since velocity equals displacement over time, the mouse moved very slow.
When Newton saw down the clown, he scurried to the minigame. This change and increase in velocity over the duration of time is his acceleration. When it was Newton's turn, he threw a ball at the clown and knocked it down.
Without the force of the ball hitting the clown would have stayed still. This motion can describe Newton's first law of motion. An object at rest stays at rest unless acted upon by a force. Newton won a prize. Newton knocked 3 clowns down.
As he was leaving with his prize, Newton saw his friend, Amanda the panda, on the bumper car line. Newton ran over to Amanda so they could go together. On the bumper cars, Amanda and Newton collided with each other. The cars bounced off of each other, representing an elastic collision. When the cars collide, Newton's third law is applied as every action has an equal and opposite reaction.
Newton feels a jolt when they collide. This is because his body's inertia wants it to keep traveling in the direction it was moving with the car, even though the bumper car stopped. Inertia is the property of matter that resists change to the object's motions.
Since Newton weighs less, his bumper car travels much further than Amanda's. This is due to Newton's second law of motion, F is equal to ma. Since the force is the same, Newton will have a greater acceleration, thus a greater displacement.
After the bumper cars, Amanda and Newton wander over to the free-fall ride and hop on. As they reach the top of the ride, their vertical position, known as the height, is at its highest point, meaning the potential energy is at its maximum. Potential energy is also known as UG equals mgh.
As the ride drops, they experience a downward acceleration due to gravity. This pulls them down. Potential energy is converted into kinetic energy, which is the energy of an object in motion, causing Newton and Amanda to speed up.
Newton and Amanda then head over to the slides. As they go down the slide, Amanda has more momentum than Newton because her mass is greater. Momentum is the quantity of mass times velocity. At the bottom of the slide, Newton comes to a stop, but since Amanda has more momentum, she is harder to stop. Amanda tumbles off the slide.
As Newton and Amanda finish the slides, they see the swing and hustle on over to the exciting ride. In this ride, Newton and Amanda experience uniform circular motion. The centripetal force, which is the force of tension from the string, keeps Newton and Amanda moving in a circle.
But then, the string snaps because Amanda exceeded the weight limit. Amanda goes flying out of the circular path because the force of tension was no longer present.
Miraculously, Bobby the bald eagle catches Amanda and brings her to safety. After catching her, he puts her in a stretcher and drags it to the medic. When Bobby pulls Amanda on the stretcher, he exerts a force on the stretcher. This causes a transfer of energy from Bobby to the stretcher, known as work.
When Amanda reaches the ground, she decides she had enough and trudges home. Newton then sees his favorite ride, a roller coaster. He goes on the ride all alone. When the roller coaster reaches the top of a hump, his potential energy is maximum. Because energy cannot be created nor destroyed, as it travels down the hump, kinetic energy increases, reaching a maximum at the bottom.
Newton realizes he has been gone for a while and chooses the pirate ship to be his last ride. As the boat swings back and forth in the same path, it is in simple harmonic motion, and one full swing is called an oscillation. The highest point the boat reaches on each end of the oscillation is known as the amplitude.
At the boat's lowest point, it is at equilibrium. Here, the velocity is the greatest. As the boat swings up and away from equilibrium, velocity decreases, meaning kinetic energy decreases, and potential energy increases. When it swings back toward equilibrium, the boat speeds up and accelerates.
After a long day, Newton decides to head on home before Mama Mouse can catch him sneaking back inside. Newton opens the door to his cheese house. The door has a force that allows it to rotate along its axis. This is torque. The doorknob is placed farthest away from the hinge to apply the greatest amount of torque when using it. This makes the door easier to open.
Newton enters his house and sees a family of evil cheese. He then hears a loud alarm.
Newton wakes up in his bed and realizes it was all just a dream.
The end.